All right, so we're going to do one more example working through a confidence interval by hand, and then we'll talk a little bit about StatCrunch. So a political consultant randomly surveys 300 voters in a district to see how many intend to vote for a certain candidate. Of the 300 voters surveyed, 165 indicated that they will vote for the candidate. Use a 99% confidence interval. Should the consultant predict that they will win the election? Why or why not? So capital N. All voters in the district. Lowercase n, our sample size. 300 voters surveyed. Our p hat. Notice that we're not actually given a percentage in this case. In this case, we're given 165 out of 300. So our p hat we can actually find by dividing those two different numbers. 165 out of 300 gives us 55%, or 0.55. Our confidence level this time we're told to use is 99%. Right. Should the consultant predict that they will win the election? So again, here we're thinking about whether or not we're above or below 50%. So what do we want to know? Does the confidence interval p hat plus or minus m stay above 50%? So that is what we are looking for in this particular example. All right, checking our conditions. Again, we're going to skip them in this case. We've done it enough so far this chapter. We're going to continue to do it through this chapter, next chapter. So again, sometimes you'll be asked to check your conditions. Sometimes we'll just skip that part. In this case, we're skipping those. So we start by finding our standard error estimate. So we're going to plug our 55% in and our sample size of 300. So 0.55 times 1 minus 0.55 divided by 300. This is going to give us 0.029. So there's our standard error. Our margin of error, we're going to take z star times our standard error that we just found. This time we're told 99%. So if we go look at our table, notice that if our confidence level is 99%, our corresponding z star is 2.58. So we're going to use 2.58 in this calculation, times our standard error, which is 0.029. That gives us 0.075. Right, p hat plus or minus m. 0.55 was our p hat, plus or minus 0.075. Again, we subtract it first and then we add it. That is going to give us an interval of 0.475 to 0.625. Right, so then our interpretation, we're going to finish this off and we will say we are 99% confident that the proportion of voters and what about these voters who intend to vote for this candidate is between 47.5% and 62.5%. So we're 99% confident that the proportion of voters who intend to vote for this candidate is between 47.5% and 62.5%. All right, our conclusion. Right, using a 99% confidence interval. Should the consultant predict that they will win the election? Why or why not? We look at these values. Again, we drop below 50%. So we will say, since the interval contains values that are below 50%, the candidate may not win the election. Again, here we aren't saying for sure which way it happens, they do or do not. We're just saying that there is a possibility that the candidate may not win the election.